This is example 2.4 on page 68 of your textbook. Here they're asking you to predict the charges of the monoatomic ions formed for aluminum and for sulfur. So before we assign these charges, I want to do a quick review on how to assign things different charges. On the periodic table, there are some very common elements that form ions that typically are always the same charge. So here's kind of an abbreviated periodic table. I've left off the actinides and lanthanides because we really won't be doing much with those in general chemistry. So of course we have the periods and rows of the periodic table, and there are 18 columns, and those are different groups, and we'll talk about those in chemistry. You got the alkali metals, alkaline earth, transition metals, halogens, noble gases, etc. So a couple of these columns, a couple of these families, all form ions with a very predictable charge. So Group 1 or Family 1, that's the alkali metals. These typically all form ions with a 1+ charge, meaning that they lose one electron to become a positive 1 charge. For Group 2 or the alkaline earth metals, most of these typically they're going to lose 2 electrons to form ions that are 2+ in charge. The transition metals are a hodgepodge, a mess. They can form more than 1 charge. Iron can have a +2 charge, +3 charge. They're all over the place. So they really don't have a predictable ion charge that they adopt. If we keep going to the right, Group 13, or sometimes 3A, depending on what periodic table you're looking at, really are only constant, predictable element that can form a predictable ion charge is aluminum. And it always forms, I'll draw him down here, a 3+ ion. And then Group 14, not really predictable charges. Group 15, 16, 17, and 18, that's where we start getting predictable again. So on this side, we're going to work from the noble gases, which is these guys, over. So noble gases, they're known for being above it all. They're noble. They don't react with anything. So typically they don't even form ions, which gives them kind of a base charge of 0. Going 1 over, we have the halogens, which are trying to act like the noble gases. So they want to lose, or they want to, they want to gain 1 electron. So they typically adopt a -1 charge. Here, I'll write it down here, -1. If we keep going over from the noble gases, we have our oxygen group. They typically want to gain 2 electrons to become -2. And then our nitrogen group, typically they want to also achieve this noble gas type electron grouping. We'll talk about that more in chapter 8. So they gain 3 electrons. Now, not all of the elements in these groups behave this way. Typically in Group 15, it's really only nitrogen and phosphorus that behave this way. In Group 16, it's typically oxygen, sulfur, selenium, and tellurium that behave consistently. And then in Group 17, it's fluorine, chlorine, bromine, and iodine that behave this way. And if you want to reference this in your textbook, figure 2.13 on page 69 has the elements and their ions with predictable charges. So, all that to say, let's predict the charge on an aluminum ion and a sulfur ion. So we kind of already have the answer for aluminum. If we consult the periodic table, this guy right here typically forms a 3+ ion. So aluminum is going to become aluminum 3+ as an ion. And then sulfur, we can look, see it's in group 16, and it typically adopts a 2- or -2 charge, so it becomes sulfur 2-. So if you'll notice, there's kind of a pattern to these predictable charges if we're going from left to right across the periodic table. And the metal side, column 1 forms 1+, column 2 forms 2+. And then if we go to the non-metal side, if we go from the noble gases over, we go with 1-, then 2-, then 3-. So we're increasing the number of electrons we're gaining as we go towards the middle of the periodic table. So hopefully this helps you with predicting some of the ion charges.